Welcome to GES Digital Intervention Program for Senior High Schools. This is Mathematics Lesson 3 on Algebra. And today we shall be looking at factorization. I am your facilitator, Nala Debu. Have you ever wondered how you can divide 342 by 18 without any stress? Do this and let me see. 342 divided by 18. I know you can do it. Let's look at a very simple way of doing this. First, I can find the prime factors of 18. And what are these prime factors of 18? We have 2, 3, and 3. 2 times 3 times 3 will give you 18. Isn't that so? Now, to divide 342 by 18 without stress, I will first take 342 and divide it by 2. And this will give me 171. Then again, I take 171 and divide it by the next prime factor, which is 3. This also gives 57. Finally, I divide 57 by the final and last prime factor, which is 3, and this gives 19. So this means that if I divide 342 by 18, my answer is 19. So today's lesson, we shall learn how to factorize algebraic expressions. Some of the keywords that will come up are factors, prime factors, quadratic expressions, and I know you are familiar with them. Let's start this way. Find the factors of 30 and 48, and then find the highest common factor. This you should do in 10 seconds. Now let's compare your results to mine. The factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. And the factors of 48 are 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. Now, if I want the highest common factor, that means among these factors, which is the highest number that is in both the factors of 30 and 48? And your guess is good as mine. 6. Let's take another pair. M cubed and m squared. What are the factors of m cubed? Here I have 1, m squared, and m cubed itself. And for m squared, the factors are 1, m, and m squared. Looking at these factors, the highest factor among the two is m squared, and that is my HCF. When you want to factorize any expression, you have to look out for the highest common factor in all the terms involved in that expression. Let's take an example. If I'm asked to factorize 15my squared minus 10my, I have to look out for the highest common factor first among the numbers, then second among the variables. So here 15 and 10 has 5 as their highest common factor. Then m and m have a common factor of m. Y squared and y have a common factor of y. Therefore, my HCF is 5my. Now I do my factorization. So I'm going to factorize 5my out. And you will now see that 15my squared divided by 5my will give me 3y. And 10my divided by 5my is 2. So my factorized form is 5my times 3y minus 2. Now let's take another example. This time our terms are more than 2. 6xy plus 3xm minus 8my minus 4m squared. How do we go about this? First, you need to check if there is any common terms or common factors among all the terms. And of course here there is none. The next thing you do is to group the terms in pairs. And of course here we have 6xy plus 3xm. And we can see there are common terms and common factors here. With 8my and 4m squared, they also have common factors. Now we can factorize them in pairs. The common factor for 6xy and 3xm is 3x. And so we factorize that out. Then we have 3x times 2m plus m. And with 2y plus m in the brackets. The common factor for 8my and 4m squared is 4m. But here, both are negative. And so we factorize negative out. This gives us negative 4m as our common factor. And so we have negative 4m times 2y plus m. In questions such as this, after the first factorization of the pairs, you must realize that the brackets are both the same. And when that happens, you combine the terms outside the brackets. So I now have 3x minus 4m in one bracket. Now multiplying 2y plus m. And we are only taking one because they are both the same. And I'm done with my factorization. You can also factorize terms that involve fractions. And when you are to factorize terms involving fractions, you consider the numerators alone and the denominators alone. For example, factorize 3q p squared divided by 20r cubed minus 27q cubed p divided by 25r squared m. In this case, you will realize that for each fraction, there is nothing that can divide. We therefore take the numerator terms alone. 3q p squared and 27q cubed and p. If you look at the numbers, 3 is common, q is common, and p is common. So our HCF is 3qp. And when we consider the denominator, you realize that 5r squared is our HCF. So here we can now factorize and we write our HCFs out. 3qp divided by 5r squared times, then open the brackets. Now let's take another example. This time, examples that contain fractions. We have to first ensure that no terms in each fraction can divide each other. If that condition is met, the next thing we have to do is to look at the terms in the numerators and find their highest common factor, and those in the denominators and find their highest common factor separately. For example, factorize 3q p squared divided by 20r cubed minus 27q cubed p divided by 25r squared m. With this example, you realize that there is no terms in the fractions that can divide. And so we go to the second step, finding the highest common factors in the numerators alone and the denominators alone. And for the numerators, 3q p squared and 27q cubed p, the highest common factor there is 3qp. And for the denominator, 20r cubed and 25r squared m, our highest common factor is 5r squared. Now, to factorize this fraction, I will now bring out my 3qp over 5r squared as the highest common factor for the whole expression. And factorizing, I'll have 3qp divided by 5r squared times p over 4r minus 9q squared all over 5m. And this is the factorized form. Now let's look at another example. But here, I want you to try it all by yourself for just 15 seconds. Now let's look at how I solved it. If you look at these three terms, you realize that there is a common factor running through all the three terms. And what is it? Okay, I know you've got it. The highest common factor is 3x. So I factor the 3x out. Now I have 3x times 4xy minus 2m plus 5b. And that is it. That is how we factorize it. And you can't go further. Let's take another one. Again, I'll give you 15 seconds to try it by yourselves. 15a squared minus 18ay minus 20ab plus 24by. 15 seconds. Let's try. Let's compare answers now. In this example, I have 4 terms. And you see, with the 4 terms, as I told you earlier, you work in pairs. We look at the first 2 and the last 2. And for the first 2, 15a squared minus 18ay. My highest common factor there is 3a. And for the last 2, the highest common factor is 4b. And when you factorize, you get your answer as shown on the screen. 3a minus 4b times 5a minus 6y. Now let's look at how we factorize quadratic expressions. I know you know what a quadratic expression is. A quadratic expression is any expression of the form ax squared plus bx plus c, where our a, b, and c are real numbers. And a is not always equal to 0. Immediately a is equal to 0, it is no more quadratic. Now, how do you factorize expression in this form? I'll take you through some few steps. Now, step number 1. You multiply a by c to obtain ac. Now, step number 2. You have to find 2 factors of AC such that the sum of those 2 factors always gives us B, and their product always gives us AC. You see the 2 conditions? Their sum gives us B, and their product gives us AC. You will replace the term in B with those 2 factors, and they will now become 4 terms. So you factorize the first 2 and the last 2. Let's take an example. Factorize y squared minus 11y plus 24. Now here, our a is 1, our b is negative 11, and of course our c is 24. So a times c is 1 times 24, and that gives us 24. Now we are going to find two factors of 24 such that when we add them, we'll get negative 11. And what are these factors? As smart as you are, I know you've got them. But let's go through another step as to how to find these two factors. First, we look at all the possible factors of 24. So possible factors, 1 and negative 24, negative 2 and negative 12, negative 8 and negative 3, negative 4 and negative 6. Why are we saying negatives? AC is positive. And so, to get a positive answer, either both factors must be negative or both factors must be positive. And as to whether both factors are negative or positive depends on the sign or the value of the b. Here the b is negative, and so both factors here must be negative. Now let's see which of these pair satisfy the term in the b. Negative 1 and negative 24, of course, they do not satisfy. Because negative 1 plus negative 24 is negative 25. Negative 2 and negative 12 don't satisfy. Negative 4 and negative 6 equally will give you negative 10, so they do not satisfy. And therefore, our factors are negative 8 and negative 3. Replacing the term, we now have y squared minus 3y minus 8y plus 24. And factorizing the first term and factorizing the first two and the last two gives us y times y minus 3 minus 8 times y minus 3. And here again, we must ensure that our brackets are the same. Then we can combine those outside the brackets. And that gives us y minus 8 times y minus 3. Let's look at yet another example. 6m squared minus 5mn minus n squared. In this example, our a is 6, our b is negative 5, and our c is negative 1. Multiplying a by c gives us negative 6. Negative 6 means that one factor must be positive and the other negative. Now let's look at the possible factors. Negative 1 and 6. 1 and negative 6. Negative 2 and 3. 2 and negative 3. Let's consider the first pair. They don't match. Negative 1 plus 6 is positive 5. The third pair, negative 2 plus 3, don't match. 2 and negative 3 are out. So the only pair is 1 and negative 6. Therefore, replacing the term in b, we have 6m squared plus mn minus 6mn minus n squared. And working with the first two and the last two, we have m times 6m plus n minus n times 6m plus n. And finally, we have m minus n times 6m plus n. Now, factorize 21x squared plus 11x minus 2. I'll give you 15 seconds to try. Now let's compare that to my solution. So here again, my A is 21, B is 11, C is negative 2. 21 times negative 2 gives me negative 42. And what are the possible factors? The possible factors here are negative 3 and 14. That will replace the term in the B. Then I have 21x squared minus 3x plus 14x minus 2. And factorizing the first two and the last two, I have 3x plus 2 times 7x minus 1. Isn't that simple? So, you can try this at home. Factorize 4p squared minus 15pq plus q squared. 2. 7 plus 5b minus 2b squared. And 3. 12r squared minus 24r minus 63. I know you've learned a lot today. What have you learned? You have learned how to factorize quadratic expressions. You have also learned how to factorize simple expressions. I will see you again in our next lesson.